Welcome everyone, and thank you for joining. In this session, we will be exploring the subject of building low-latency websites with Amazon CloudFront. My name is Kamil Bogacz. I'm a solution architect specializing in edge services, and in my role, I'll help AWS customers to navigate through technical implementation of Amazon CloudFront and perimeter protection services. Later in this talk, I'll be joined by my colleague, Philippe Cheng, who's software developer manager responsible for building Amazon CloudFront service. Here's what we'll be covering in this session. We'll set the stage for explaining why performance even matters and what are the other challenges and recent trends in web development landscape present. From there, we'll move quickly to CloudFront and establish the basic understanding of how the way we build its underlying infrastructure and design the caching architecture improves web delivery. Next, we'll share with you a practical approach on how you can maximize the caching benefits, followed by outlining edge serverless options and what you can achieve by moving your application logic closer to the edge. Finally, we'll illustrate the importance of using modern web protocols in serving your website. Over the years, companies of different shape and size running online business have learned how performance of their websites affects the business outcomes. Going all the way back to 2006, when Amazon.com shared that every 100 milliseconds in page delay can decrease the sales by 1%. And we find that almost 15 years later, from a study published by Deloitte, that only reinforced that claim with a clear evidence how site speed impacts the sales in retail operations. So the old truth hasn't changed. The customer engagement strongly depends on the performance. What has changed over that time span is technological landscape, and with it, new challenges that arose. We witnessed the page bloat, a progressive increase in average website size, which between 2010 and 2017 grew from 700 kilobytes to 3 megabytes. And it shouldn't come as a surprise, considering images and videos can make up more than 60% for a typical page size today. What it is emphasized is that you need to stay ahead of the curve and continue to accelerate delivery of the website to stay within the same time budget that you still have. There's much more device diversity too. It's not just desktop computers anymore. Mobiles, tablets, and smart TVs make a significant share of global web traffic at present. These devices have different capabilities and are usually on different types of networks. So in order to provide the same user experience, you need to account for that and be able to adjust your website based on the client's characteristic. And by the same token, example of the website that some of the devices can take excessive time to load are so-called single-page application website, which push the load associated with constructing the page to the clients. This is widely known as client-side rendering paradigm, that requires the viewers to run heavy JavaScript code to generate the page. So that said, if you can identify traffic coming from less capable devices, you can offload them too. For example, by serving more lightweight version of the website optimized for specific device category. The approach for building and maintaining the website changed as well. By the means of web builder type of services, you can build professional looking website where with simple visual editors or content management system, content team can focus on what matters the most to them, creating high quality content without deep technical expertise in web development. Even for more advanced use cases, development team choose some form of specialized services like static object stores or API gateways. And these are well suited for hosting websites and eliminating much of the operational overhead. These tools have been designed for convenience of use and to provide the core functionalities most of the website need. This works well to the point where the new requirements comes up, like, hey, we need to add the set of those security headers to the responses. And you only then find out that it's not always possible with these tools. And it doesn't mean you shouldn't use these services, but to retain the same level of control and flexibility, you should front them with the layer that provides the level of required customization and set of the common features that allows you to deploy your custom logic when needed. So each of these challenges I mentioned can affect the scores your website gets from search engines. And that translates into how much visibility your site receives. For this reason, it's the key element of online strategy to adapt search engine optimization practices. SEO is all about you do to provide best user experience, and site performance contributes to a large extent. Many of you might have heard about Core Web Vitals. It's a set of free quantitative performance metrics defined by Google, which represents how quickly viewers can see your page, when they can start interacting with it, and visual stability of the layout. Starting this year, these metrics were added as a ranking factor in evaluating Google's PageRank score. So if you want to see your website higher up in the search results, you need to improve page load time as well. Next, take a good care of how you manage redirects, as the chain of the redirects can also lead to the worst user experience. SEO engines are also very rigorous about using the right status codes, and if you don't do that properly, it can have unexpected bad results. It can happen especially in these cases where you have limited control over how your origin manages status codes and redirects. Similarly, another SEO optimization to consider is to use user-friendly URL containing the keywords descriptive of the content on the page. If the URL generated by the origin is not like that, you should look for an option to employ URL rewrites to manage viewer-facing URL format. Also, going back to the previous slide, SEO crawlers represent the type of traffic that you should handle differently in certain situations. So remember, it's an automated piece of software running in an environment different from the ordinary browsers. And it also has very limited time to spend on your website before it moves on. Some of them would still not support popular JavaScript frameworks that you use to build your interactive pages. So by providing them with a pre-rendered version of the website that's easy to parse and index, you can stay assured that your website will be processed properly by SEO crawlers. Now you went through the challenges of the present, let's start talking solutions by bringing into the picture Amazon CloudFront, which is AWS Content Delivery Network, or CDN in short. And let's see how it helps in overcoming aforementioned challenges. Adding CDN into architecture is an elemental step in improving the performance on your website. It brings the web application closer to the viewer with its global footprint and accelerates the entire delivery path all the way up from the origin to the viewer. With that, let me hand over to Philippe, who will talk about CloudFront architecture.
I want to start with what is the most fundamental element of CloudFront in delivering a better user experience, and that's its global presence. Your customers are diverse and global, and the best way to serve them is by making your content available from a close proximity. The distributed nature and capacity scale of CloudFront has been important more than ever in the last year and a half as the global pandemic changed the online landscape. For our customers, it entailed steep growth in the traffic of existing applications, as well as pushed them to move more of their operations online to adapt to a new reality and to secure their business continuity. For CloudFront, that resulted in 80% year-over-year growth in terms of bytes served, and we're staying ahead of the curve as we keep on growing our global footprint at an accelerated pace. We reached a mark of 300 points of presence spread across 47 countries and 90 cities, and these numbers increase almost every week. This doesn't even include our fastest growth segment, embedded POPs, deployed deep within network providers to offer the best possible connectivity. CloudFront POPs are connected by the AWS Private Backbone network built on high bandwidth and redundant links connecting CloudFront POPs with the AWS regions. This internal network offers the highest throughput and is also fully redundant with active monitoring. If any networking issues occur, we call this internet weather. Internal alarms will trigger and activate automatic mitigations to route around the failures. The benefit of this backbone is that we are able to build large regional edge caches that are well connected to each edge POP. At the outreach of this backbone lies our edge POPs, which are strategically located to give the best coverage across local network providers through direct peering connectivity. So how do we manage all of that connectivity? Let me tell you a personal story. Many years ago, when I started at CloudFront, we had an operational event where heavy traffic congestion was seen all across Europe. Every alarm started firing all at once. What the is going on? Then I noticed the folks around looking at me. What are we going to do? All right, let's take a look, I said. Well, this is interesting. The traffic is not supposed to be here. There was a surge of traffic from Eastern Europe all funneling into Sweden, congesting every single link across the board. I made a few configuration changes, checked them with the team, and about 30 minutes later, poof, all the traffic is draining and now nicely spread out across Europe. I went home that night and told my wife, I think I'm going to like it here. The internet broke in Sweden and we fixed it. She looked at me, smiled, and said, you're right. You're right on time. Your daughter has a dirty diaper and this isn't going to change itself. We've come a long way since those days. CloudFront has built an extensive set of systems of monitoring and automation to manage all of the connectivity. Today, these systems will shift and balance traffic 24/7 for most situations. The bottom line is, with a rapidly growing global footprint, CloudFront will help you providing low latency performance to your viewers in the parts of the world that will give you the capacity to scale for the largest online events. Coming from that global footprint view, how about we zoom into how the CloudFront architecture looks like and explain request and responses flow with more depth. The main objective is to minimize the distance and latency from the viewers to your application. With your user base spread across various ISP networks globally, CloudFront will be for the most part just one hop away. As each request moves over these peering links, it will reach one of the edge locations in the first tier of caching, made up of a large number of high-density POPs. If it happens that a requested object is not in cache, the request will be sent upstream to one of the 13 regional edge caches with even larger cache width that assures greater object retention and long-tail content. Only when the requested object is not present there, then we go forward to the origin for retrieving the requested file and record that as a cache miss in metrics and logs. Keep in mind that edge locations, recs, and origins, when hosted in AWS, are interconnected through private, high bandwidth, and redundant AWS backbone network. That's the key for maintaining high performance and availability for our customer workloads, as any type of slowness or packet loss between customer-facing cache layer and the origin would have a noticeable blast radius. By running CloudFront on top of the network, we shield you from the internet instabilities. So when multiple requests for the same object are received before the object is cached, CloudFront sends a single request to the origin and uses that single response to serve all the viewers. Think of a sporting event or any other live stream. Suddenly a surge of viewers will be requesting new segments of bytes every few seconds, but everyone will be requesting the same new set of segments. These will all collapse at each layer until only a very small number of requests hit the origin. This translates into a clear performance gain, as all the requests after the first one will piggyback on it and experience lower latency. When CloudFront goes forward to the origin, it doesn't close the connection when it's finished downloading the object. It will keep it open, and subsequent requests that come in may come in. This particular mechanism goes a long way to improving latencies for API-type workloads, as it greatly reduces the connection setup delays. Now at this point, the content is cached at each edge location used to provide low latency access. Lastly, an origin shield can be utilized to provide an additional layer of caching in front of the origin to help scale and protect your origin requests. This short overview of CloudFront's inner workings should have given you a picture of what it is about CloudFront that provides low latency delivery control over your traffic. Before we go further, let's break down the topic of performance into 3 dimensions that we will use to frame the rest of the presentation. Caching. This is the foundation of what CloudFront does as a CDN, so we'll explain what we can do to get the most out of it with the right caching strategy. Application. Here we won't be talking about the best practices in structuring your pages or web development techniques. Instead, we'll uncover how you can leverage edge compute to make your website more performance efficient and how it can alleviate some of the issues we explained in the beginning. And protocols. We'll look into HTTP protocols and discuss which one fits your workflow and take a peek at a new standard. And for that, I hand you back to Camille.
All right, so let's start with caching and the question, what's the premise of caching in terms of performance? In general terms, the idea is that you store the application content in the place with a quick access so that the future requests for that content can be satisfied faster. As you can recall, the reason this is important is that while the average website size grows, you still operate within the same time budget. You just have a few seconds to deliver your content to the visitor before they give up and close the website. By using CDN for caching, it's just more feasible to stay in that assumed time limit. As we are on the subject of caching, we should first understand what's the key metric that shows how well the caching works and be a good starting point to reason if your viewers get a good performance. In the world of CDN, that key metric is cache hit ratio. Put simply, it's a metric which indicates what percentage of the requests were served from CloudFront cache, and accordingly, the remainder will be the percentage of requests that resulted in a cache miss and had to go to the origin. Any caching strategy that improves that metric should be taken into consideration, as maximizing the cache hit ratio translates into direct performance improvement by reducing the average response latency. In contrast, low cache hit ratio results in more cache miss occurrences and means more requests need to take longer path to the origin. So before we explore what makes good caching strategy, I would like to walk you through the process of how CloudFront caches your content. Let's take a look at the example here of a website served by CloudFront. When Alice sends a request for a contact page, and that request reaches CloudFront, the very first thing that needs to happen is to calculate a cache key. Cache key is a unique identifier of the object in cache. It is built from specific request attributes and associated with the cache response from the origin. The primary attribute that makes the cache key is request URL path. In this case, that will be /contact. After the origin responds with the requested object, the second step in the process is to calculate time to live, or TTL in short, which is basically an expiry timer for a given object. Resulting TTL is a product of two things: max age value included in a cache control header coming from the origin, and the TTL setting you in your CloudFront configuration. Normally, CloudFront applies max age value, which is origin's indication of the desired TTL, but only as long as this value is within the range defined by minimum and maximum TTL setting. If that's not the case, and max age value is below or above that range, CloudFront will use maximum or minimum TTL values respectively. There's also a third setting, and that is default TTL, which defines the value CloudFront uses when cache control header is missing from the origin. So let's come back to Alice. After the cache key was calculated, original page has been retrieved from the origin and the right TTL was set, the response makes its way back to Alice. Within that TTL period, when another request within the same URL path comes in from Bob, CloudFront will evaluate the same cache key as for prior requests and conclude it can return previously stored response. However, what happens when you have more than one version of the contact page, for instance in different language versions? How you can cache multiple variants of the same page using the same URL? So that's simple. Just add the right attributes in the cache key definition, the ones that affect the response returned by the origin. In case of different language version, that attribute can be accept language header that browsers use to indicate preferred language version. Now, when Alice and Bob make a request for a contact page, they will get different responses corresponding to their preferred language. Why? Because now accept language header, being a part of the cache key definition, results in a different cache key ID between the viewers. And that's simple and logical, but we missed one important detail. There's actually much more values that accept language can equal to, as the request comes from global audience. And you can choose to default to the English version if you don't have a specific language variant of the page for each variant. However, at that point, you could start losing some of the caching efficiency, because each variant of the accept language header will produce its own unique cache key. And as a result, the default English version of your page will be fetched from the origin and stored in cache multiple times to satisfy each variation of accept language header independently. And this will reduce cache hit ratio metric, the very one that we want to keep high to maintain the great performance. As you move on to defining the right cache strategy for you, the first thing on the checklist is to slice and dice your website for different types of content. If you take modern websites such as Amazon.com, you'll see it's a product of multiple discrete components with a varying caching characteristics. It's vital you also clearly identify those components on your website and think where and for how long those components should be cached, or if they should be cached as a matter of fact. So CloudFront supports whole site delivery with so-called cache behaviors. which allow you to create content grouping defined by the URL path patterns. Each of these content grouping can have separate cache setting attached to it, and even point to a different origin, so you can build your single website using various services in the backend. So let me illustrate what that means in practice, staying on that example of e-commerce website. Clearly, you'll find some dynamic elements like shopping cart status, last purchases, or even your name being displayed. Very often, these elements would be supplied by API endpoints, and this type of information is private by its nature. Thus, you wouldn't store that in a public cache. For this type of traffic, appropriate setting would be to disable the cache in the first place. And that's something that can be easily done in the cache behavior settings, where you can select from the list of managed caching policies and choose the one that prevents CloudFront from caching API responses. Although these responses are not being cached in this case, your viewers will still experience better performance from reusing persistent connections that we talk about and other optimizations that we'll cover later. So moving forward, you can expect e-commerce website will be filled with images of different sort, like ads, products, or banner images. This is not private content whatsoever, and that's exactly the type of content to cache for as long as possible. There's appropriate managed policy for that as well, with predefined settings well applicable for static content. For each of those policies, you can see that what TTL settings are as well, which I encourage you to do to get a better understanding of what will be the resulting TTL once the object is retrieved from the origin. In this example, we keep the images in S3 bucket, where by default, S3 won't add cache control header that would inform CloudFront for how long it should cache specific object. In this case, CloudFront would use default TTL from cache policy that would evaluate to 1 day as a default TTL. So last piece of the puzzle is public but mutable content like HTML files. While these are cacheable and shareable among the viewers, it's not something you always like to cache indefinitely. Like, assume you have your homepage and that is something you like to update every few minutes, so that the viewers don't hold on to the same version of the website for hours. In this instance, you can define your own custom caching policy that would include more tight TTL range that you would accept. Now, when origin returns HTML page with, say, 60 seconds of max age value in cache control header, CloudFront will validate if that's within the defined range and apply this value if that's the case. All right, you build the right caching strategy and you keep cache hit ratio in check, which goes already a long way in reducing the page load time. After you maximize cacheability of your content, the second page in Performance Playbook is to look at minimizing the size of the original content, as this will also lead to less number of bytes that you need to send to the viewers. Specifically, you should think about the resources involved in so-called critical rendering path. And this is a sequence of all the initial steps that browsers have to complete in order to display anything on the screen. So it heavily depends on files like HTML, JavaScript, or CSS files that determine the structure and layout of the page, all of which are text files that can be also effectively compressed with algorithms like gzip or Brotli. And in particular, employing the latter one can bring noticeable improvement compared to gzip, which has been prevalent format over the years. CloudFront supports both of these formats, so make sure you use it as well. So what does it mean CloudFront supports compression? It comes down to two things. First, it has to do with content negotiation and cache key normalization. You can't just send compressed file to the viewer unless you know that the recipient can actually accept the file in this format. HTTP protocol addressed that by including accept encoding header in the viewer request, detailing what formats a client can work with and even what's their order of preference. Although there's not that many formats out there, values of that header can vary a lot, as various clients would construct that header differently. It's the same problem we outlined previously, in which high variance of the header lead to object duplication and poor cache hit ratio as a consequence. To avoid that, CloudFront applies additional processing of accept encoding header, by normalizing its value and reduce that variance only to few values corresponding to broadly, gzip, or uncompressed version only. Because that happens before the cache key is even evaluated, that effectively improves cache hit ratio by preventing object duplication problem that we learned about before. And the second feature CloudFront offers with respect to compression is an opt-in feature to compress automatically the objects that Origin is not able to do. It's an optional setting you set per cache behavior, and it applies both for broadly and gzip. Now, I want to go back to the other challenge I outlined in the beginning, which is differentiating your website for various devices. To adopt the principles of responsive design means you are able to recognize the requests coming from different ends of the device spectrum and present to them a version of the website optimized for their varying capabilities. As an example, a common strategy is to assume lower page size and time budget for mobile devices, which tends to be on a slower network. So after you put together mobile optimized page, you need some signal that you could pick from the request to determine if this is coming from a mobile device, and only then send back the right version. The only way to achieve that is to look at user agent into user agent request header. That single header conveys all the information about the browser version, device type, operating system, which translate into the thousands of unique values of this header. Therefore, it's clearly a bad idea to include this header in a cache key, as it ties back to the same problem of object duplication to a very large extent. Fortunately, CloudFront comes with a solution for that by supporting a set of utility headers that CloudFront generates for you to make viewer segmentation easier task without sacrificing cache hit ratio. Coming back to our example, based on the user agent header, CloudFront would generate on the fly a simple header indicating if this request is coming from mobile viewer or not, assuming one of two values, true or false. Not only your Origin can use that header to respond with the right version of the website, but even more importantly, from a cache key perspective, adding CloudFront generated header, you get a clean cut based on the device category instead of 1,000 values of user agent header. And this is very important to keep caching hygiene in check. And here you can see a full list of CloudFront supplied headers that can help you in segmenting your viewer base, not only per device category, but also by viewer location. This facilitates producing and managing highly localized content as well. So let's move to the application level optimization. We'll focus on how you can take advantage of Edge Serverless to improve the performance by executing your application logic closer to the viewers. We'll also discuss how you can deploy the required functionalities that sometimes are not available at the origin, as we explained in the introduction, or simply it wouldn't be optimal to run them at the origin from the architecture perspective. So how you should think about Edge Serverless? The idea is quite simple, actually. As you saw, CloudFront runs on top of globally distributed network of edge locations, which cache and process your content as a part of native feature set. And the premise behind Edge Serverless is that you actually use some of that distributed capacity to allow customers run their own logic, while still the core of your application or business logic, if you will, would be run in AWS regions of your choice. What you should be looking for is to identify these self-contained functionalities that you want to apply in your workflow, but that wouldn't be necessarily what constitutes the core of your application. If you can safely decouple those pieces of functionalities from the origin, these are good candidates to run at the edge. One of the reasons why you would consider that instead of traditional approach of managing the fleet of reverse proxies instead, is that very often by promoting the logic to the edge, you end up with better cacheability and offload your origin from undifferentiated heavy lifting. For some of the functionalities, using Edge Serverless option is the only sensible approach as well. For instance, when you want to perform advanced routing logic in multi-origin scenario. So here are the benefits that stem from using Edge Serverless. For one, performance gain by promoting application logic closer to the viewer. And you'll find latency improvement will be especially notable when your custom code can render an entire response without consulting it with an origin, as that will eliminate some of the backhaul round trips between edge locations and the distant origin endpoint. It also gives more flexibility. Refer to those scenarios where you rely on web builders or managed services. Edge serverless creates that additional layer where you can add custom functionality not available at the origin, while you don't have to give up on convenience of use that these services provide. Third, there's origin independence. To the previous example of e-commerce website, it's not unusual to use multiple services at the origin, providing different components on the page. However, the feature set and configuration process is different on each of these devices. An even simple thing as setting cache control headers will give a different experience for the developers. So by keeping this common set of features with Edge Serverless, you get consistent developer experience and functionality no matter what's the origin service of your choice. Lastly, customers appreciate its cost-effective, simple pricing model going as low as $10 per 1 million request. So there are two Edge Serverless environments customer can choose from. First, there is Lambda@Edge, being an extension of Lambda service. This is AWS flagship serverless product, allowing you to run your code in response to the predefined triggers without managing any underlying infrastructure. So Lambda@Edge can be seen as a general purpose tool that gives you the most abilities in executing your code, as it's fully functional environment with adjustable compute resources. It's perfect for more complex use cases from functional standpoint, as it supports using external libraries or making external network calls from the function itself. Some typical examples of use relate to server-side rendering, where for simple requests, you can even render a response at the edge without even going to the origin. Lambda@Edge is also a common integration point with SaaS vendors offering advanced bot protection or image transformation solutions, where Lambda@Edge can initiate the request to those external services and wait for the results to come back. As with any Lambda-backed workloads, you need to be mindful of some of the scaling consideration, though, in terms of concurrency, requests per seconds, burst limits, and as the traffic on your application grow, stay on top of these limits and make sure that you work with AWS to adjust them appropriately. The second option is CloudFront Functions, a new Edge serverless environment that has been specifically designed to streamline developer experience for much simpler use cases, which are prevalent in what we have seen in customer architecture. With CloudFront Function, you can run short-lived and self-contained functions that wouldn't require external network call or using external libraries. The range of application that fits in CloudFront Function includes mostly header or URL manipulations, managing redirects at the edge, or stateless authorization workflows. So this can make a perfect fit for some of the SEO-oriented customization that we already talked about. One of the key benefits of CloudFront Function is that it removes scaling considerations relevant for Lambda@Edge, as CloudFront Function is meant to follow the scale of CloudFront and support the largest workloads in terms of scale. And if you wonder why we have both, well, it's a very common approach for AWS if you think about its general philosophy of having the right tool for the job. So on one hand, you have general purpose solution with most level of control and flexibility, and then you have options optimized for very specific use cases. To better visualize how the request and response flow changes with CloudFront Function and Lambda@Edge, let's look at the provided diagram, which puts that in perspective. The code you run with CloudFront Functions will be executed in edge locations that makes the first viewer-facing layer of caching. So with CloudFront Functions, we bring your code as close to the viewers as we possibly can. And note that CloudFront Function logic can be only invoked in response to so-called viewer-facing triggers, namely viewer requests and viewer response. These triggers are invoked on every single request and response exchange between the viewer and CloudFront. What's interesting is that viewer request trigger invoked when a request lands on CloudFront, it is invoked before cache key is even calculated. So this is great power of it when you think about it, as it provides you an opportunity to normalize incoming request parameters and that will be the way to maximize the cacheability of your content. As we move to Lambda Edge, it also offers same viewer-facing trigger as CloudFront functions on the viewer-facing side, but keep in mind that they can be used in conjunction for the same cache behavior. What's unique about Lambda Edge, though, is that it provides origin-facing triggers too, origin request and origin response respectively. And these triggers are perfect for any type of logic that doesn't need to be enforced on every single request, as the number of invocation will be effectively reduced to the small percentage of cache misses occurrences or dynamic requests. As you can also see, in case of Lambda Edge, your function will be executed in the nearest regional edge cache location. Now I want to talk about real-world example of how one of our customers, Contentful, benefits from CloudFront and Lambda at the edge. Contentful is a cloud-native headless CMS powering digital experiences. It provides content infrastructure and API for managing, storing, and delivering your application assets across multiple delivery channels for the devices of different shape and size. CloudFront has been the right match for the scale and global reach that Contentful operates at, and also for supporting performance requirements by caching the assets closer to the viewers and applying other delivery acceleration techniques. One of the important aspects for Contentful is to have the ability to run additional logic on the request path before it's forwarded to the origin. That's exactly the right job for Lambda at Edge, as it creates the layer of required customization. Using Lambda at Edge made it possible for Contentful to include in their workflow a detailed asset management by connecting Lambda at Edge to their backend API, supplying metadata about the requested piece of content. It also performs request sanitization to ensure requests match the expected format and prevents sending requests which is known to produce an error at the origin. On top of that, Lambda at Edge allowed Contentful to run their service in multi-origin configuration with advanced load balancing and stateful failover mechanism that makes their service highly available and minimize potential performance impact during an outage. Lambda at Edge is also an integration point for image transformation service used to deliver original image in optimal format and size for a given client. In this scenario, in addition to request validation and sanitization, Lambda at Edge also performs attribute mapping. This ensures incoming request parameters stay within acceptable range of values and match the expected format of image transformation endpoint. Important design principle Contentful pay a close attention to is making sure that those external endpoints Lambda at Edge communicates with are also distributed by their nature, so that when Lambda at Edge function is invoked closer to the viewer, it doesn't need to take a long path when reaching out to one of those endpoints. That's what keeps performance metrics in check as well, and we strongly recommend that you embrace the same approach when you integrate Lambda at Edge with any external services. And all of that happens in a natural flow of the request towards the origin and is performed closer to the viewers. Contentful experience and sentiment highlights how CloudFront and Lambda at Edge together checks all the marks in respect to additional control they require at the right performance. So something you probably wouldn't expect me to bring up at this point is AWS WAF. But actually WAF has a role to play in managing different types of traffic too. Traditionally, AWS WAF role has been security-centric. If you are not familiar with it, it's an HTTP service which inspects incoming traffic to determine if this is malicious request and that should be blocked. Otherwise, when it evaluates it's safe, it allows that in. So great thing about AWS WAF is that it can be easily integrated with CloudFront without any re-architecturing involved. And this year, we released a new feature for WAF called Bot Control, which is AWS managed mechanism for identifying bot-originated traffic. This feature gives you fine level of control over what sort of bots you want to allow and which one you want to restrict. It works in quite simple way, as in when a request comes into AWS WAF, it will run it through Bot Control Engine, which will mark that request with so-called labels. These labels carry additional information on what category of bot that is, what's the name of it, and whether it has been verified that this is coming from authentic source. And for the type of bots that you welcome on your website, again, think about all the SEO crawlers indexing your site, you can further convey that bot identifying information upstream by inserting the custom WAF header. This header would give you the signal that you need. Hey, let's give a pre-rendered version of that website for this bot request, right? And you can pick that and process that header at the origin, or by using CloudFront function, you can change URL requests on the fly to serve back a pre-rendered version of the website. And this is very useful when you use S3 for hosting your website as an example, as S3 can only use URL path to differentiate between the objects. What I'm going to show you is how easy it is to apply viewer segmenting using CloudFront. The goal is to serve the right version of the website for different clients while still maximizing caching efficiency by avoiding content duplication effect. So imagine you have your website that you have been using for both desktop and mobile viewers. Now you get to the point when you want to build a new version of the website for mobile devices that you want to progressively roll out. And assume you only want to send 50% of your mobile viewers to the new green version of the website, while the rest will remain on the default blue version. At the same time, the traffic from the desktop users should stay unaffected and stay on the blue version of the website. To accomplish that, we will make use of CloudFront's generated header, indicating if viewer is using mobile device or not. In this example, we'll use a website written in React, one of the very popular single-page application framework, which is a sort of website that can be problematic for SEO crawlers. For them specifically, we will use WAF bot control feature to help CloudFront in identifying this type of traffic and send it to the static version of the website that will be easier to parse and index. And the central point of that workflow will be CloudFront function, bringing all these conditions together. And because we store all the assets on a S3 bucket, our function will have important role in mapping the information from the relevant headers to the target URL path corresponding to the right version for a given client category.
All right, so we are in the CloudFront console. Let's navigate straight into the default cache behavior settings. What you'll see here is that there are two functions associated with these cache behaviors. There's a viewer request function, traffic segmentation that we'll look into the details of. And there's viewer response function, which sets the cookie in the response to provide the session persistent, so that the subsequent requests coming from the same viewer will end up on the same version of the website. All right, so let's into the traffic segmentation function, which is the key in this workflow. The very first thing we do in this function is we look for the existence of WAF supplied header. And that header is specifically an indication of whether bot control associated that request with the SEO bot that we are looking for. If this is the case, we'll change the incoming URL on the fly and modify it to /SEO, which will then return the pre-rendered version of the website. The next thing we do for the actual viewers visiting your website is we check for the existence of the segment cookie. The segment cookie, it's a value which will determine if the viewers will see blue or green version of the website. If that cookie hasn't been set yet, this is where we will randomly generate that value and then set it as a cookie in response. And the last most important thing for that blue-green deployment strategy is we check for CloudFront's generated header that depicts if this is mobile viewer or not. If it is mobile viewer, and at the same time the segment value is above the threshold of 50, this is when we will send that viewer to the green version of the website. Otherwise, it will stay on the blue version. So let's see how that actually works in action. So here I'm on the website that we are working on. As you can see, this segment value is above the threshold that we set, which is 55. And I don't see the green version of the website in this case because I'm coming in as a desktop viewer. So I'll always end up on the blue version of the website. However, what happens when I switch to the mobile view, because of that segment value being above the threshold that we set, I'll see now green version of the website. And if I modify the value of that cookie to be below the threshold, I'll see the blue version of the website. So this is how you go about deploying blue-green deployment strategy. All right, so the next thing I wanted to show you is how you can provide pre-rendered version of the website for SEO crawlers. So this is how original HTML document looks like when it's downloaded from the origin. As you can see here, there's nothing in the HTML structure that can be displayed on the screen. It's very simple in its structure. As you can see, the key part of that HTML doc are references to the JavaScripts at the bottom of it. So what happens is those JavaScript needs to be executed in order for anything to be displayed on the page. As you can see, if I invoke those scripts, it's only then when you see the modification on the page and that new elements appear on it that are now being displayed. And because SEO crawlers, some of them wouldn't be able to execute those JavaScript parts of the page, here we're going to provide them with a pre-rendered version of the website. So to show you how it works, let's switch very quickly to the WAF view. And here you will see I have two rules. The very first one is associated with the bot control engine. So this is where the labels will be set, identifying the incoming bot. And in the second rule I have here, over here, I'll be setting this custom header that I'm checking for in the function itself and set the value to SEO and true. So now what happens is when I'm coming in as a bot, so in this case, I'm using a utility tool called curl, which will be captured by WAF and identified as a bot traffic. The appropriate header will be set, Cloudrun function will pick that, and will change the URL appropriately. And as a result, you'll see that instead of getting the base HTML document with the references to JavaScript, here I'm already getting HTML with static references to all the objects.
All right, now that we show you a demo, now we're going to move to the protocols underpinning web delivery. We talk about performance improvements Cloudrun brings by getting closer to the viewers with your content. The second side of the coin in accelerating page load time is to harvest the enhancement that modern application and transport protocols can offer. With that, let me invite Philip, who will walk you through the details.
To optimize performance, it is recommended that you choose the right HTTP protocol to suit your needs, and it's not always obvious. HTTP 1 is the first mainstream protocol dating back to 1997. Its simplicity is its strength. The TCP stream is just plain data of raw file contents. There is very little overhead, and you can transfer a small number of large files effectively, one at a time. Typical ideal workloads include large downloads and streaming video. However, for many workflows, including downloading many small files such as websites, HTTP 1.1 might not be the best choice. With one request downloaded at a time, it is susceptible to head-of-line blocking, where one request, either due to loss or network congestion, will block everything else. HTTP 2 was introduced in 2015, supporting multiple streams over a single TCP connection. That means that you set up a single connection, meaning DNS, TCP, and TLS can then be downloaded multiple times simultaneously. Each stream is independent. If any are slow, it does not block or hinder the other streams. Additionally, HTTP 2 introduces header compression. If you are downloading hundreds of files, you are likely sending the same set of headers for each of them, which for very small files could be a large percentage of the load. HTTP 2 will compress these down to approximately 33%. Lastly, HTTP 2 supports stream prioritization to help speed up critical requests. So let's see these in action. In this demonstration, I show the difference between HTTP 1 and HTTP 2. This website loads 100 independent images, which are combined into one larger one. First, we have HTTP 1. Browsers today will utilize 6 independent connections, so while the connection can only support one download at a time, in browsers this is partially mitigated. Notice that in the waterfall view, requests are downloaded in batches of 6, but each connection is sequential. With HTTP 2, however, a single connection would be created, but all files would be downloaded at the same time. In some scenarios such as this one, the page will finish rendering significantly faster. There is a bound, however. If download speeds of the viewer is very fast, then it doesn't really make a difference. If the download speed is extremely slow, on the 2G connection for example, then you'll be limited by the network and have a similar experience regardless of which protocol you use. However, head-of-line blocking is where it makes a difference for the user experience. In this demo, I replaced 6 images in the center with a large version, but scaled down to the same size on the page. These are small enough to block the flow and make you wait. In the HP1 version, everything stops after all 6 streams are tied up. However, in the HP2 version, there is no blocking, as each file can be independently downloaded. The overall time to download all the files is the same, but the experience can be very different. Now, let's move on to what's next. This year, HTTP3 was ratified and represents the future of HTTP. Let's take a look and see what we have to look forward to, as this is a major improvement to the internet in general, particularly in emerging markets. HTTP3 is built on top of QUIC, which is a transport protocol that is meant to take the improvements from HTTP2 and evolve past TCP's limitations. From HTTP2, we have multiplexed streams. By replacing TCP, we now have true head-of-line blocking avoidance, since TCP streams cannot be blocked by one stream getting packet loss or hitting congestion limits. By making TLS an integral part of the design, the handshake is cut in half, from 2 RTT to 1 RTT, and as low as 0 for resume sessions. And lastly, my favorite part is connection migration. If users have the connection severed midstream by switching apps on their phone or switching to a new tower, HTTP3 will carry forth with no interruption. This is really exciting, and I can't wait for HTTP3 to become widespread. To recap, we have taken you on a grand tour to cover challenges facing modern websites, such as SEO optimizations and the need for low latency performance. CloudFront performs this by providing a vast network of high-density POPs close to viewers, backed by the titanic size of the AWS backbone that provides internet connectivity with high throughput and fully redundant connectivity. We have demonstrated how to optimize your caching performance via a combination of native headers and cache policies. We have covered serverless options, including CloudFront Functions and Lambda@Edge, to bring your application logic closer to viewers to improve performance and even improve caching rates. Lastly, we guided you on the different HTTP protocols and when to use each, with a peek into the benefits of the next iteration. It was our pleasure to be able to share with you everything that we were excited about. Thank you.